Hello and welcome everyone to another session of Manufacturing Future from Industry 4.0 Club. My name is Jan Pingo and I'm joined here with our co-host Mike Unger and our guest of the day, Steve Hoffmann from YZ Systems. We unfortunately don't have our regular host, Ira Sharp. He was not available today, so Mike has graciously offered to join us today and help kind of ask some good questions to Steve as we go through this topic here. So welcome, Mike. For I think it's the first time you've been on as a co-host on Manufacturing Future. So thanks very much for joining us.
Thanks, Jan.
So we're here today. This is a new area that we want to talk a little bit about is connectivity. So connectivity for IoT, and today we're going to talk about a fairly new technology called LoRaWAN. And Steve, he's one of the experts. And just for transparency, Steve from YC System is actually a colleague of mine. So when I'm not here with these great people, I'm a product leader from Ingersoll Rand, where I'm responsible for digital solutions, which is mainly utilizing IoT to make our equipment smart and connected. And Steve kind of works in the same area of IoT, and so we work together once in a while on some areas, but not regularly. But it's good to see you here, and looking really forward to hearing what you are working on with LoRaWAN. So that was a quick introduction to me. Mike, if you want to introduce yourself as well.
Thanks, Jan. So my name is Mike Unger. I'm like Jan. I'm one of the co-founders of the Industry 4.0 Club. The club's purpose is to help advance the deployment of Industry 4.0, really to improve our competitiveness with manufacturers here in the United States and abroad. My background, I spent 35 years with Michelin in a variety of leadership roles in continuous improvement, operations, finance, and HR. And today I'm a business coach and executive coach, helping business leaders achieve their real potential. Anyway, I'm happy to be here today to join the Manufacturing Future broadcast.
Yep.
Thanks, Jan.
Happy to have you. And hey, before I hand over to Steve to introduce himself as well, if you are there live watching, please feel free to enter questions in chat, either on LinkedIn or YouTube, and we will answer them as they come in. And looking forward to any questions you have as we go through this topic here today. But Steve, over to you. Please introduce yourself and let's start hearing about what you guys are doing with LoRaWAN.
Absolutely. Thanks. Appreciate it, Jan and Mike, for having me on to talk about LoRaWAN. So Steve Hoffmann, I'm the Managing Director of Aircom IoT Solutions as a part of YZ Systems brand. We acquired a company based in the UK that makes LoRaWAN products in the fall of 2022. So since then, I've been helping run that business, and then we've been expanding the product offering and services, et cetera, to really leverage LoRaWAN in industrial platforms, right, to get data back to customers' fingertips.
Great. Yeah, and I mean, it's one of the topics I've been very interested in because, I mean, if you look at traditional IoT type connectivity today, it's pretty much focused on either typical Ethernet, Wi-Fi, or cellular communication. Most likely for connecting to the cloud. But LoRaWAN is kind of a different technology. It's somewhere maybe in between. And so I'm interested to get your perspective on where it might differ and what it can offer for different types of solutions, and what are those type of solutions where a manufacturer might think about LoRaWAN as an alternative to what you traditionally would want to look at.
Absolutely, because ultimately data is what everybody's trying to get back, right? So you've got the things to make decisions, right, about that process, application, et cetera. And there's a variety of different technologies out there that allow you to bring that data back. And ultimately, it's about finding the right technology to help solve whatever the challenge is in the business. And just to give a little bit of background on LoRaWAN and the overview of it, so it stands for Long Range Wide Area Network, and it's part of the low power wide area network family of technologies, which we'll see more on the next slide. So it's on the license-free sub-gigahertz radio frequency. Depending on the region you're in, it'd be 868 megahertz in the EU, and then in the US, 915 megahertz. And key benefits and why it's such a powerful technology for people to consider is it's very low power. So you've got battery-powered edge devices taking sensor readings, transmitting long distances, with a secure encrypted protocol. So it really checks all the boxes around cybersecurity for industrial platforms, range and distance, and really when you're talking about low data rate sensors where you're just trying to bring back temperature, pressure, other values like that. So in the overall ecosystem, and I think it's important to look at this because all of these technologies serve a purpose, right? And just depends on the application.
Mm-hmm.
If you look at it there, you got bandwidth and battery power on the y-axis, and you've got range on the x-axis. So you've got the more traditional kind of IoT, or home type technologies where Wi-Fi, Bluetooth, Zigbee, that are short range, but have a variety of bandwidth options and power draw options available versus, say, your cellular, which is going to be, it's going to be very high on energy consumption, but can transmit, fairly long distances. Then you've got the low power wide area network family of technologies where LoRaWAN sits. They can send data up to 10 plus miles, depending on the topography, right? But do it at very low power. So you can have a battery powered edge device that lasts 2, 3, 4, 5, even 10 years, depending on the application.
So it looks like the range, you said 10 miles. That's quite a range for something that is a small kind of device sitting at somewhere in a factory, whatever. And you normally don't think about like comparing it to Zigbee and others that you have that kind of range. Does that mean that you will put a whole infrastructure around that large range? And what are the type of solutions that you see today are looking for that kind of range when you're talking about connectivity?
Yeah, ultimately, there's a number of factors that come into that range, which, when you get into deploying LoRaWAN, you've got end nodes that transmit data packets to a gateway. It's a star topology. So it's not a mesh network. You've got them communicating back to gateways, but you can have multiple gateways. So you can have redundancy. So you could have, say, 5 gateways covering a facility, right? That helps you build out a robust network that picks up all the LoRaWAN data packets being sent back and then forwards them to a central server where the data is decrypted, and then sent on to the business system, right, to be able to make decisions, right, based on the data coming back in. So it typically starts with looking at essentially kind of a coverage study, right? So deploying a gateway, testing coverage at the extremities of the area you're looking to test, and making sure that you've got coverage with the gateway deployments you put up. And then from there, you can really start to expand and then add, additional end node locations.
Well, Steve, when you mention a coverage study, it's not just, correct me if I'm wrong, but it's not just the geography, it's also how much data and how much frequency. Am I right in thinking that way?
Those things all play into it. So with LoRaWAN as a protocol, when it's joining and transmitting data packets, it's trying to optimize data rate because there's different data rates through the LoRaWAN protocol. So it's essentially negotiating to be able to optimize for power and distance within the protocol. And then with that, you are limited from a packet size perspective. So you're never going to use LoRaWAN to send, images or stream video or anything of that nature. It's very much meant for sensor data where you want to take bytes of data and transmit those at kind of infrequent intervals to maximize battery life, et cetera, for those applications. So, when you look at this is a great image that just shows the different technologies and how they actually work together. So for our products, for instance, we use BLE for the configuration of our device, right, on a mobile device, which is pretty typical for LoRaWAN. You see a lot of manufacturers leveraging BLE for the configuration. We obviously use LoRaWAN as the communication protocol to send the data, And then from the gateway needs to be connected to the internet, which could be through an Ethernet port, or it could also be through a 4G SIM card, right, for the backhaul to be able to get the data back. So ultimately, it's not that any one of these technologies is the solution, and they can all work together, right, to make a very powerful solution for the end user.
And we say BLE, that's like the Bluetooth connectivity from your phone to the device, right?
Exactly. Yep, the Bluetooth low energy connectivity from your phone.
Yeah, that's cool.
Are there cost considerations? So can you give us a sense of I mean, maybe it's not the right question to ask. I'm not sure about the relative cost of these different approaches.
Absolutely. So, if you were to consider it, let's just say because you look at cellular and you look at LoRaWAN, for instance, on there, they can send data similar distances. We tend to take for granted the fact that there's, cell towers all around us, right? If you start looking at any, water towers in your area or anything, you'll see that there's cellular receivers typically up on those, same with tall buildings. And you forget, you don't understand or know how many of those receivers exist to allow us to communicate with each other. And ultimately with LoRaWAN, it's building that infrastructure. You can build it out yourself. You can use public networks. There's a lot of different ways to go about it with it on. But as far as from a cost perspective, because you're transmitting in the unlicensed band, you can do LoRaWAN really cheaply because you can buy the hardware, right, and deploy it yourself and pay no data transmission costs at all.
Wow.
Or you can meet somewhere in the middle. Whereas if you go with, say, cellular, right, you have to have a SIM card. You're going to have a monthly fee associated with it, et cetera.
That's one of the. Oh, sorry. Go ahead, Mike.
No, I was just saying that's really interesting because I think it's when you start recognizing the characteristics. If you go back to that last slide for a second,
yeah.
If this is accurate, it shows some overlap in systems. So really understanding your needs and where they come together can be really important from not only a coverage and data, the amount of data interested, but also the cost you have available to spend.
Yeah, I mean that to me is the very interesting part about LoRaWAN is that when you look at any other technology, so if you're looking at Wi-Fi or Ethernet, well, you are setting up your infrastructure in your facility. If you're looking at 5G or LTE, right, you're connecting to some vendors, some provider like Verizon or T-Mobile or AT&T, whatever, right? There's not that many that are capable of setting up their own 5G local network, even though there's an option. So mostly you're either doing it yourself or you're doing it all through some kind of vendor where you have to pay for it. Whereas LoRaWAN is like in the middle again, where you can decide that you want to set up your own network and connect back. And you might be paying for the backhaul, as you were saying, Steve, but there's other options in LoRaWAN too, right?
Exactly. If you look at the other three options listed beneath LoRaWAN there, those are all in the LPWAN family of technologies, but they rely on cellular infrastructure. So it's a telco model. So you essentially need to have that monthly recurring fee associated in order to communicate. They're just more of a, small data rate, low power, right, cellular option, if you will, that exists out there depending on the application again. And I think that's the biggest thing for these, for manufacturers and companies to consider these days is how do you look at different technologies to consider them and how they best fit into helping solve problems, right, that you've got around getting more visibility to more data so that you can, make better, faster decisions related to manufacturing and other things of that nature. So being able to just consider a technology, test it in some kind of a lab type environment and be able to then open that up to your engineers when they're going out there to solve a challenge, right? Which could be that we need to see this pressure or a pH value, let's say, that's a 1.5 miles away from the facility, but you've now got the ability to do it because you're leveraging LoRaWAN, and you've got the ability to send that data from 1 mile away back, right, for monitoring the pH value of, say, effluent or something else. So a lot of powerful use cases. And ultimately, I think it's just a matter of being able to put LoRaWAN into the approved technology bucket so it can be leveraged. Because ultimately today, it's easier than ever to bring any of these protocols back to a central dashboard or interface to be able to see the data. So the protocol is really about what's the problem, what's the data I want to see, and what's the right solution for it. If you need real-time data monitoring or you want that kind of live connection or you need, video, you're probably going to leverage Ethernet or cellular, right? if you need to see pressures, temperatures, things like that from long distances, LoRaWAN's a very strong contender in there because
And
of the
if
background.
you're in a like a city area, my understanding is too that you could actually connect to some public LoRaWAN type network. I'm assuming you have to pay for that in some way as well, but you are able to set up some pilots and test something out without having to set up your own infrastructure, right? If
Absolutely.
you are in those areas, of course.
Yep, there's a number of different companies out there that are deploying public LoRaWAN networks, or you could think of it as third-party LoRaWAN networks, where they're deploying the gateway infrastructure to build the coverage network, and then you're able to leverage that coverage and send data, typically at a cost that's a fraction of what the cellular network is. So that's your cost advantage of it, and then be able to leverage that low-power secure technology that LoRaWAN brings, but not having to figure out how to get coverage over wide areas. So it definitely just depends on the use case.
Right, yeah. And so I pulled this one up here again, or not again, but just to show a little bit of that. I mean, the 10 plus miles, and I think the cybersecurity part of it is what most manufacturers are looking at, right, to make sure that this is really where it fits into our manufacturing industries, as opposed to some of the other technologies for IoT out there that are really just on a maybe like a hobby based kind of things, right? That some people are starting to play with and use, where this comes out of the box as a secure, capable type of solution. Plus, you have the ability to buy or purchase devices, because it's all open and interconnectivity, right? You can buy a temperature sensor from some company, and a gate frame from another one, and a flow meter from some third party or whatever, right? And combine those together in a single system without having to worry about proprietary type solution, etc. Right?
Exactly. LoRaWAN has the flexibility to kind of meet businesses where they want to be with different solutions that are out there around it. So it's nice because you're not tied into a proprietary solution, right, with any one vendor. You've got the flexibility to like you said, you could have 10 different end nodes from 10 different manufacturers that you're using to get different data back, right? Again, solving the whatever the problem is. There's also some devices out there that are sensor agnostic and can be configured, right, wired into any analog, digital, serial type connection.
Right.
And then same thing goes for the gateway and the cloud server. There's a variety of vendors, and you can choose which vendors you want to work with for those different pieces. But it also de-risks that something should change, and all of a sudden you invested heavily as a manufacturing company if you were to say in a proprietary technology, and then if that company sold or shut down or whatever, right, that puts you at risk. But with using the LoRaWAN as an open protocol, you've got that ecosystem of devices and everything that's there supporting it, so that you can choose the end devices, the server, and the gateway that are the right solution.
So what is the technology to connect? So I'm assuming that LoRaWAN is its own technology. So if I look at an end node to a gateway, there's some protocol things you're going to set up. But once you're from the gateway and up, how do you configure those? What is the technology that you got to know and implement in your solution to be able to be, what do you call, LoRaWAN compatible, or whatever you want to call it?
Yeah, so there's a LoRaWAN Alliance, and then there's different things you can do out there with devices where they can have the kind of LoRaWAN, tested and approved stamp on devices and other things. But ultimately, it's just about following the implementation protocol for LoRaWAN. If you think about it, with this is a typical setup for LoRaWAN, where you've got end nodes that are sending data to a gateway. It could be multiple gateways. Those gateways are pointed to an IP address, and they forward those data packets to the IP address, where ultimately the cloud server then decrypts and shows it. But as a part of that, in order to make it work, you have a 128-bit key, right? And there's each device, each end node has its own unique identifier, right? EUI number associated with it. So that comes from the factory with the EUI. You can set the key as the manufacturer, right? So you control the key, right? You can change it. You can set it to be whatever you want to. You can randomly generate it. You put that same key on the end node. You put that same key into the cloud server. And then there's a join process where the end node joins. Typically, a lot of manufacturers will use this over-the-air join, where it will handshake to the cloud server and issue what they call an app and a network session key that it then uses for encryption and communication going forward. So it's quite simple to, right, once you've selected the cloud server that you want to use, then you can, right, and you've got the end nodes you want to use. All the end nodes are going to operate very similarly to that, right? The interface might be slightly different with the configuration tool for each one, but it's going to be an app key. You're going to have a device EUI. You add that on the server, and then you can ultimately then join the network and start sending data.
Steve,
yeah, go ahead. Go ahead, Mike.
Yeah, Steve. So that's really cool. The technology. How long has this been around?
So LoRa, kind of the base layer chipset technology, has been around really kind of since 2012 when Semtech bought the technology. And then they created and founded the LoRaWAN Alliance in 2015. And then have really been building on it since then. And with the LoRaWAN Alliance, right, they're looking at and releasing protocols and always looking to add kind of new features that can be adopted that help, further the value add for LoRaWAN. Such as recently, they came out with a new release that also has what they call a relay feature in it, to where now you'd actually be able to put a relay device between the end node and the gateway if you've got some really long distances and you maybe can't get connection, right? Because of where you can put a gateway and where the end nodes need to be, you can now put a relay device in there that'll basically catch the data packet, and then essentially you could think about it as forwarding it onto the gateway. So it's a unique part about LoRaWAN, and because it is a protocol like Bluetooth, Wi-Fi, and others, where they just keep improving it, expanding on it for businesses to build off.
That's really cool. Yeah, that's really cool. So it's really a young technology in many ways. Then it sounds like
it is. And if you think about it, even though I've always been a home IoT nerd, if you will, and playing with those technologies, really starting with like Z-Wave, Zigbee, and other things, right? Probably in more like 2010-ish type time frame. And then they really saw this need and this gap around long range technologies that could do similar things for battery power, because ultimately that's the challenge for a lot of customers and manufacturing facilities out there is, I would love to pick up this data, but running power over there just does not make sense, and solar solutions can be rather expensive, right? So, and that's one of the unique things about LoRaWAN. Depending on the application, you can get in nodes ranging in price from $50 to sky's the limit. And the kind of same thing goes for gateways. There's very basic gateways, and then there's gateways with more features, bells and whistles, etc. So you can choose what you're looking for in that ecosystem.
Cool.
Yeah. I put up the slides around use cases because I think you have some interesting images around use case as well. But the obvious ones, of course, is industries where they have large, like outdoor type kind of facilities, like a petrochemical plant, water treatment plant, tank farm, ag tech, whatever. Right? There's a lot of opportunities there, as well as doing it in a large indoor facility as well, of course. But especially on these very large outdoor plants, that it's really hard to come up with the right solution there, oftentimes, because running cable is really expensive, and if you got to put a cellular connectivity to every single device or sensor out there, that's very expensive as well. So there's definitely some industries that could definitely benefit from that. And as I mentioned when we talked earlier, I was at the ARC annual conference in beginning of February, and I was on a panel with a engineer from Chevron, and they're starting to put in LoRaWAN in their facilities all over. And again, as you say, because it's very straightforward to pick up. I think that's one of his terms for just to start building a system with it was very straightforward because of the way that it's open. You can go buy a sensor and test it out and get some value from it, and then you can start defining what it is you really want to do, and then develop those type of systems. But that's an obvious solution, I think, for that type of industry.
Absolutely. And, we'll get into some of the pictures of what, I think it's easy. I like showing an outdoor because it's easy to visualize the value that it adds. Because to your point on a lot of these other technologies, they don't have the range to be able to cover an entire facility. And some of these facilities could be, a couple square miles even. But with being able to deploy gateways, and you could have 3 gateways, right? And some of the benefit of LoRaWAN is having the ability to deploy redundant coverage so that if you should lose power to a gateway, for instance, or there was an issue, you don't lose visibility to the data because you can build redundancy into that as well. Picks outdoor coverage, which is a natural value add in wastewater treatment or a petrochemical type facility. Because you can deploy the gateways to build coverage, you can deploy gateways indoors, right, underground, et cetera, and build coverage wherever you need it versus, having to rely on, say, cellular coverage where it's only going to be wherever they've put it, right? You don't have an ability to influence that, where with LoRaWAN you can. And even then, we've talked to some customers where using LoRaWAN to help them bridge out data to a place where they do get reliable, say, cellular backhaul, because maybe it's in a valley where they're trying to pick up, a well site or something that they don't have good cellular connectivity to. So they use LoRaWAN as a way to bridge that up and out as well. So lots of different interesting use cases around LoRaWAN and being able to give visibility to the data.
So when you say underground, I know that in a mining industry, oftentimes it's hard to get data, and it's expensive to run lines into deep into mines. Is that an opportunity for LoRaWAN, or I don't know exactly how it will navigate when you get obstructions, like mining will have obvious obstructions, of course.
Yeah, absolutely. I mean, so it's one of those where just the other week I was out in our manufacturing facility and deployed a gateway in like our server room, which is back kind of in one end of the building. And then we had deployed some end nodes out on the other side through numerous walls, and we were able to join, send data, et cetera, going through that. So it will bounce off of the walls and navigate itself around. And that's why I say kind of there's a couple steps to it, which you start deploying LoRaWAN. If you're going to do something like that, just deploying a gateway. And then because you're talking about battery powered handheld type devices, and they make some LoRaWAN range testers as well, you can walk around the facility and see where you might have a spot where you're not getting the coverage you want in an area. And then ultimately decide, do I move a gateway, adjust the gateway height, or maybe put up another gateway to build that coverage. And there's tools out there like this one that we have, which is proprietary, that we built for our own use, that allow you to say, note the gateway location and the height, and then it'll approximate the coverage based on the topography, right, in that area. And ultimately, some of those things will then determine, right, if you got a big mountain on one side of the area, you're not likely to be able to communicate over to the other side of that mountain. And that's what you get to see here is step one. We'll usually always start with the customer looking at a computer study like this, and then we'll move into, right, if they move into a bigger deployment, doing a physical study out in the field.
Right. Yeah. And I mean, you develop your tool. I'm assuming there's other tools out there, but it's something that you're not used to, right? In a typical like study, if you're doing a cellular study in a factory, it's contained to a fairly large but still kind of small area. You don't have to think about topography, right? But that's some of the things that you got to think about here with LoRaWAN, is to look at where do you have valleys and where do you have mountains, and how does that all fit together? That's a very interesting concept as well, I think.
Exactly. I mean, this picture is really showing more of a distributed over a very wide geographic area type technology versus, where it's being readily adopted, as you noted, with Chevron and Total and others, because you've got these centralized facilities with a lot of different data points in that area. And LoRaWAN's great for that because of the fact that it supports a lot of different frequency bands. So it allows a lot of devices to communicate on that LoRaWAN protocol, and sending that sensor data back to give them visibility with battery powered end nodes. So that's the simplest solution, because you take out a lot of the complexity you see here for trying to cover a very large geographic area when you're talking about covering a refinery or one of those smaller facility than, say, North Texas, for instance, or something like that.
Right. Mike, you had a question?
Well, I was thinking about, and I don't know if you have any, and we didn't talk about this in advance, Steve, so I don't put you on the spot a little bit, but um, do you have any case studies where companies have implemented this and, they've, the ROI or the benefit that they've received as a result of going this route versus another route?
There's different case studies that are out there in the marketplace for LoRaWAN and the advantages it brings. We're working with a couple of customers to put together some case studies specific to applications that we're focused on with our products. But there's definitely a lot of information out there on the value proposition and why you want to consider it.
I was thinking, we're always trying to promote just getting started in Industry 4.0. And I can just imagine, going back to the earlier picture of, let's say, a water treatment plant where, 10 years ago, my morning routine is to get in my truck and drive to each location, okay, and make sure that everything's working correctly. And by the time and then if I find one that's not, I finish my route, then I got to come back, get the parts, and go back out and fix it, right, or something like that. And then the really cool part of that, this I guess I can just imagine is, for those that haven't gotten started on this journey, this is a relatively low cost for the right level of data that you're trying to gather. And instead, I come in and I look at my dashboard. I see where the issues may lie, and I get the parts I might need to go address something that's unusual. And but by noon I don't have anything else to do. So but it's a very interesting proposition and quite a neat ROI for this sort of an application.
And it's kind of, you think about it, it's a really powerful tool for condition monitoring of different assets that you'd have around a facility. So if you were to take, say, a wastewater treatment facility, you're probably going to have mixers that are on site. You can monitor, say, vibration, which would be a key data point for mixers. You're going to have a bunch of different chemical injection type pumps on site, and you can then monitor vibration, pressure, temperature of those pumps or other inputs there. And then, like you said, instead of today where you may have a maintenance person that goes around, you now start to digitally monitor those, and then you can set threshold limits and other things when you work with the manufacturer, right, to kind of create this digital twin and be able to then understand, hey, I need to go look at this mixer. Looks like a bearing might be starting to go in the gearbox. I need to go look at this versus, what, it looks great, right? Exact same baseline of vibration as it's been for the last 3 months. I don't need to worry about going over there right now. I'm going to focus. And really, instead of being reactive, you can be a little bit more planned in your approach, right? And try to keep max uptime on all processes.
Well, and even to the point as you just described, now I gather this data, and I don't even need somebody on site. I could be in a couple different. If I have a distributed organization where, I have a couple sites over, let's say a county, or a couple of counties, I could be at a central spot and be really, really effective and proactive, as you mentioned, with my monitoring and my repairs.
Yeah, but I was we had another session at the last conference I was at where I had an opportunity to talk to him afterwards. But he was presenting the idea that he had created in a skunk works kind of environment, had created a little package with a cellular communication on it that he would give to his guys. Say, okay, if you have to go out and look at wellheads and do some testing on a regular route every day or every week, whatever, here instead, take this with you next time, go install it, and we'll configure it into our system, and then you'll be able to kind of be more effective. But these were expensive tools he put together, just because it was with cellular communication. It of course had you got have a subscription, right? But for their application, it was still well saved. But I'm thinking even with this here, you're getting to a much more easy way of justifying it because of the cost is a lot lower, and you don't have to necessarily always at least think about the cost of transmission, because you might be running it on your own network for free. So these are interesting things, especially if you can have somebody, save the time of having to go out every day. I mean, they'll be happy if they can put a couple of these devices out in the different places they got to go, and then only have to go out when they're an issue that they can see with the data. So that's a cool
Exactly. And you've seen a lot more, there's a lot more options coming into the industrial space around LoRaWAN now as well with device manufacturers, et cetera. For instance, our product is very much focused on hazardous locations. So we make an intrinsically safe product that sits right in explosive environments and can monitor data and send it wirelessly, which is a very unique value proposition. And then to your point, right, there's different price points depending on the problem you're trying to solve in the environment that people are in, but they've got the options to pick the right kind of price point and solution to address that need.
Actually, yeah, absolutely.
Steve, what kind of growth, so without divulging corporate secrets or anything, but what kind of growth have you seen over the last couple of years with this technology?
So in general with LoRaWAN, right, there's 100 million plus devices that are out there and connected. You're seeing a lot of growth with LoRaWAN globally. It's growing at, double-digit CAGR from an adoption perspective. And we've seen the same thing within our customers. And it's all about where you're starting that conversation, which is why I was promoting that manufacturers and businesses should just be looking at and evaluating technology for consideration. Because ultimately, if let's say we show up to a customer, because we've helped another customer solve a problem, right? So we go to another customer in the same industry, but if they've never heard of LoRaWAN, right, then it's a bit of an uphill battle because not only are we trying to tell them and sell them on our product, but we got to sell them on that technology first, which is a steeper hill to climb than just telling them, hey, we got a great product that can help solve this problem for you. So there's some of that in just education, which is why it's great to be able to come on a show like this and be able to talk with you guys about LoRaWAN, because I think there needs to be more of that out there. Because ultimately that's, when you're talking to somebody, they're like, wow, this really looks like a great technology. This would solve the problem. But cybersecurity, it's got to go through corporate approval, et cetera, et cetera. And then that slows down the ability to implement solutions. Those are really important steps in every organization to vet and look at cybersecurity. But how do you do it proactively, right? To open up options for your engineers to solve problems.
Well, I don't think we've talked about that. You mentioned cyber, but or maybe you mentioned it in passing, but maybe we could reinforce that the encryption capabilities of this technology. Talk about that for a second.
It's 128-bit encrypted data standard with LoRaWAN. So all the data packets that are sent are 128-bit encrypted, and you set the key. And then ultimately, even once you've decrypted the data packet on the server side, then it's essentially a payload of bytes, and you have to have the payload decoder to then break that down into actually getting the data back. So if you looked at it end to end, it's a very secure protocol for sending sensor data, and it's most often used really for monitoring data in the field, not as often for two-way communication, although it does support uplinks and downlinks, but it's primarily used as a way to get uplinks or data from the field to give you visibility to a sensor. So when you think about it like that, it helps reduce risk around things around cybersecurity as well.
Yeah, it's not like so. For example, what I do at LoRaWAN is connecting our equipment, which often have 100, 200 different data points, and we're collecting data at at least a minute rates and point it up to the cloud. We also don't have the capability to write back. That's more from a decision perspective, because we want to make sure that our customers are comfortable that we cannot do anything. We can't change the set point or anything like that, because that's not our goal with the IoT. But with LoRaWAN, it's oftentimes you're connected to a single sensor, and there's nothing the sensor can do except sense. And so data is just coming one way, right? And even if you could send to it, you could probably change it from Fahrenheit to centigrade or something like that, but that would be it, right? So there's not a lot from a cyber security perspective that you often would look at in that for LoRaWAN, but it's definitely something that it has to be secure in some way, and this is more built-in security from the beginning, whereas most other application you got to build that on top of it, right? So even when we're building ours, we had to build in security on top of it. It wasn't coming directly from like the protocol we were using, but this protocol has it built in. So that's also, I think, a very big deal. But I am interested, though, when you say 128, that almost sounds a little dated now, potentially, with what's going on with some of the technologies that are starting to be able to break those type of security. So I don't know, is that something that they're working on? 256, 512, 1024, whatever, that you could choose that and upgrade it to a higher level if you needed to.
That may be something that comes out in the future state with LoRaWAN as it continues to evolve. But ultimately, even if you wanted to brute force hack 128-bit encryption, you'd need a supercomputer and a lot behind it, right? So we often talk with our customers about, if you set your key, right, to join, your 128-bit key is all zeros, that's not a very secure way to manage it, right? So if you use a random number generator and other pieces out there, right, it's an extremely secure protocol. You can even develop your own internal policies where, say, you want to change the key once a year and then rejoin the network, right? And it issues new keys to use for data transmission. So there's ways you can build in additional cybersecurity on top of, right, the protocol. But ultimately, that 128-bit standard encryption has been tested and approved by the likes of Chevron and Total and others, right, to be secure.
Right.
You know what? And it may be slightly different direction. And again, because I'm a bit of a novice when it comes to this technology, I'm assuming then, based on our conversation today, that I wouldn't transmit like a video or a picture. Just as too much. Am I right in saying that?
Correct.
Okay.
Yep.
Yeah. Let's say you have a temperature sensor sitting in a tank somewhere.
Right.
How often would you be able to pull that temperature?
So it depends a little bit.
On average, just I know there's a lot of depends, but on average.
Yeah, so with the regional parameters, if you were, say, in the EU, you'd be sending the data, the max frequency would be about every 4 minutes or so that you could send the data back.
Okay.
And then in the US, it's a little bit different. You could send the data back more frequently. You could send it every 30 seconds, but your data rate is limited more in the US, depending on the spreading factor. So it just depends regionally. But oftentimes when I talk to customers about it, I think one of the considerations is, especially for businesses that are looking to adopt LoRaWAN but have been using maybe a wired technology, and they're used to, say, we just decided that we would pull this data back every 30 seconds. The question I always just like to get them to think about is, what decision, if you were now to get the data every 4 minutes, what's the potential risk to the business? Or what would you have done if you had that data 3 minutes earlier that you can't do now? Or is this still acceptable, right? And just reconsidering options that give you the visibility and still meet the needs of the business, right? Even if it's less frequent data.
Yeah, and I mean, it also depends on the application a lot. I mean, so when I was managing data historians, I often talk about how they collect data, right? And so, for example, the temperature is a good example. So if I was going to collect the temperature from a mixing tank, I might want to get that temperature once a minute because it's going to change, and I want to get at least like every degree change that it'll come out with, and that's probably just around that point. When you're looking at this picture here, you're looking at one of those huge oil tanks, probably, right, or gas tanks sitting out when you drive by. I mean, if they change every 10 minutes, I think that's probably then something it might be even going wrong, right, when it's full of liquid, right? So it all depends on the application, and so again, that's back to what you said originally. As a manufacturer, you got to look at what are you trying to accomplish and what is the right technology for it. And I think that there are places where LoRaWAN is not the right technology, and that's just okay. And then there's other places where it's an obvious technology that you should try to use. And again, you can also mix and match, right? You don't have to go one way. Depends on what it is you're trying to do and what the data that you're trying to connect to and how what that means to you and how it's generated, right?
Yeah, because you can often find that a business maybe trying to look for that silver bullet, the one technology that does everything out there, and you could leverage, if cost is no object and you've got power everywhere, you can leverage cellular, and if that's the way you wanted to go. But I think it's valuable for businesses to look at and consider different technology options that are out there. One of the mass use case options for LoRaWAN would be things like automated meter reading or things like that, where you might want to connect or have a connected sensor on, say, a water meter or a gas meter to a house, where you're ultimately just trying to send a data packet a day that says what the usage was, right?
Yeah.
So now you can have that 5-10 year battery life, right? Sending that one data packet a day that gets the critical data back to them that they need, right? That they were otherwise sending, humans around to collect prior to having ways to do it in an automated fashion. So that's a powerful example of LoRaWAN at scale. And then to your point on the other ones, just it's all about the application at hand. If you're monitoring, say, tank level in a tank that changes level very slowly, every data twice a day might be enough for that use case.
Yeah, and then when you mentioned battery, we haven't talked a lot about that, but that we've mentioned it. But that's also, I think, a very critical element of deployment here is that you can actually experiment with deploying sensors and test out the solution. Whereas if you're going to do either Wi-Fi or if you're going to do a cellular, well, you got to run power. And so that's typically a big hurdle on going out and trying something even in a plant, is that I've worked with various different customers where, trying to run power can take months just to get the contractor scheduled and project and whatever up and running to get that out. Here you put a sensor out with a battery on it and you got instant data and you can see what it can do for you. And then if you need to pull power later on when you have a more stable solution, then you can do that.
Exactly. And there's LoRaWAN solutions like those that we actually provide from the YZ Aircom side of things that also can be connected to any, essentially, like, think of it as a dumb sensor, just a wired sensor you wire in, and it can provide power to that sensor. So it can loop power it, take the reading, and then transmit it. So you can essentially add, right, LoRaWAN technology without having to go replace all these sensors you've already invested in, right, around the facility, or be able to add additional visibility to other aspects of it. So there's so many ways that can add value.
Yeah, this has been a very interesting conversation and a topic that I think we really need to look more at, because there's a lot of opportunities for starting to look at different technologies to solve the problem or the challenges that you have. And this is, as we mentioned, a fairly new technology out there that does bring some interesting perspective. And I just put this slide up here that kind of shows the summary about where we are. I mean, just the mere fact that you have this wide area of both pricing and applicability for this, you have an opportunity to do some piloting of something fairly inexpensive, and then once you identify that there's value in it, you can come up with the right solution based on what it is you want to do. And this is very, very interesting technology. I think I'm starting to see manufacturers looking into this in the U.S. as well, and I think Steve, you're seeing it as well too. And I think it's going to grow, because it is a different technology that kind of sits in between the more traditional ones that can solve a problem that you normally would have to put a lot more effort into to solve with those traditional technologies.
Absolutely.
So before we end our conversation here, any last thoughts, Steve, that you want to make sure that anybody listening in here will take back from our conversation?
I think depending on your role inside of an organization, if you're a leader in a business, right, promoting technology adoption and figuring out how you get people the ability to test things in advance, I think just helps open the toolbox of options, right, for the team to go out there and do the things that you're asking for. So I think that's a key piece. And then the other part of it is, if you're listening in and think this would help your organization in some way, right, be the champion that brings it to your boss and says, hey, I'll run the pilot and do these things. It is very easy to deploy a LoRaWAN proof of concept test. We do it with customers all the time. It's a real easy way to start. We can get them up and going in an hour, right, testing the product. So all those things, and ultimately, pick the right technology to solve the challenge at hand. Yeah,
absolutely. Mike?
No, great. I really learned a lot today, Steve. I appreciate your time and the conversation. I'm a lot smarter than I was an hour ago. So thanks.
Absolutely. Yeah. Well, let's wind down here just for everybody that's listening in. Again, this was the Industry 4.0 Club, our Manufacturing Future live stream. We are streaming typically at this time at 12:30 to 1:30 Tuesdays and Wednesdays with different topics. We are. I don't know, Mike. You have one tomorrow, I believe, right?
Yeah, we have a broadcast tomorrow. Mike Yost will be talking to Drew Croats, a recording that was done back at IME West.
Yep.
Talking about the Industry 4.0 Club specifically. So anxious to hear what Mike has to say about the club.
Yeah, and I think our Women in Manufacturing is next Tuesday.
Yeah.
Next week. So please join in and listen in. Another good topic in sustainability that they're bringing in here, which I think I can't remember if the one next week is Deborah Dahl, but at least that's also one of my favorites, talking about circular economy. So please join in on that one as well. So with that, thank you everyone for listening in, and check out LoRaWAN. Check out the LoRaWAN. What's a foundation or organization? I can't remember.
It's the LoRaWAN Alliance.
Alliance, that's right. Yeah, check out more information on that and see if it's something that makes sense for your organization. With that, thank you very much, Steve, for joining me here. I really appreciate you and appreciate the information you gave. It's been very informative and at least left me with some thoughts about what to do next in different elements that I'm looking at to connect information back into our system. So great conversation. Really appreciate it.
Thank you.
Yeah, thanks. With that, we'll end it for today, and please join in next week, join in tomorrow, and join in next week, Tuesday and Wednesday.